I want to look here at how we can calculate empirical formula. So remember that the empirical formula is the simplest whole number ratio of atoms of each element in a compound. So really to do this, we're going to follow two steps in a way. We're going to find the number of moles of each element which are present, and then we're going to find the simplest ratio of moles. So for our first step to find the number of moles of each element, we know that moles equals my mass divided by my MR or my AR, okay, if it's just an atom. So because this is going to be atoms, we're really going to be looking more at the AR than the MR, but there isn't really too much difference. Of course, that is just the mass which you would get from the top corner of your periodic table. Now, one thing I'll say about the mass is in these questions, sometimes you'll see the mass as an actual mass. So, for example, 50 grams or 10 grams must always be in grams. Okay, if you're actually using an actual mass, so if it's kilograms, converted into grams. But the other thing is sometimes you will see the mass not given as a mass, but given as a percentage. So the first example that we're going to look at here, we actually do have percentages. Now, I don't want you to actually worry about this as 20% magnesium. Try maybe to think of it as 20 grams of magnesium. So if we go back to our two steps, so our first step is to find the number of moles of each element. So I'm going to find the number of moles of magnesium, the number of moles of sulfur, and the number of moles of oxygen. So to calculate my moles of each element, I'm going to take that percentage and divide it by the mass of each element. So I have 20% magnesium, so that's going to be 20 divided by 24, which is the mass of my magnesium. For my sulfur, it is 26.6, so it's going to be 26.6 divided by 32, because 32 is the mass of my sulfur. And for my oxygen, it's 53.3 divided by 16. So if you use a calculator to work those out, that will give you 0.833 moles of magnesium, 0.831 moles of sulfur, and 3.33 moles of oxygen. So that's my first step. My first step was to calculate the number of moles of each element, so I've done that. My next step is to find the simplest ratio of moles, and I do that by dividing through by the smaller or the smallest value. So the smallest value that I have here is 0.831. So I'm going to take each of these numbers and I'm going to divide them by the 0.831. Okay, so my second step, 0.833 divided by 0.831, 0.831 divided by 0.831, and lastly then for my oxygen, 3.33 divided by 0.831. Okay, so dividing each of them by that smallest number, that then will give me 1.002. Okay, so that's basically 1 for my magnesium. It'll give me exactly 1 for my sulfur, and for my oxygen, 4.007. 4.007, which is essentially 4. So what we're looking at here then is that we have 1 magnesium, 1 sulfur, and 4 oxygens. So that means that my empirical formula for magnesium, 20% magnesium, 26.6% sulfur, and 53.3% oxygen is Mg, one of those, S, one of those, and then it must be O4 because I have a 4 here. So my empirical formula is MgSO4.